Let us see how it can be done programmatically. We have created the linked list here and we have added the strings to list in line number 62. We have to call this new function to sort the list in ascending order based on numbers. So we will call this function as sort linked list ascending based on number. Sort linked list ascending number. We'll name the function like that. It's a void function, it doesn't return anything. We have to compare two adjacent members in the list. So we need to have two pointers called current and previous. You can name the pointers anything you want. I'm just calling it as current and previous here. Since they are pointing to our linked list, they obviously have to be of type struct num and string. They are pointers, they are of type pointers to struct num and string. And I will also have one more pointer called temp node. This temp node is meant for a node that gets removed like this. Let's say the number the node 9 gets removed, right? That is assigned to temp node when it gets removed. This list has to point initially to the original list. So we will assign this current and previous pointers to the list head, which is ns underscore list, which we have as our global variable. Initially I will check if ns list is valid at all, because if it is null, we don't do anything, we can just return. It's worth doing something only if this ns list is not null. In that case, we have to start processing the list. So I initialize current and previous to ns list, and we will have the usual loop that we have to traverse the list while current not equal to null, current is equal to current of next. That's what we had earlier in two places, when we tried to print a list and when we traverse the list in order to insert a string in each of the members of the list. We did it in task 2 and 3. Almost the same logic here to traverse the list from beginning to end, from left to right. So we have to check two adjacent nodes. If current's member, we are going to check the member of the structure elements. So I am comparing the number field of current and previous. If current's number is greater than or equal to previous number, it's already in ascending order. I don't have to do anything here. I have to just skip this node and go to the next node. So when we move ahead, we have to move both the pointers. So now previous will be equal to current, and current will proceed to the next node. Else in the else part, current's number is actually less than previous's number. I'm just adding it in the comment so that it's clear when you read the code. In this case, we have to remove this current node and stitch the list appropriately. So when we want to remove this node, we just store it in a temp node. Look at this picture on the right side. So let's say we are removing this node 9. So node 9 gets assigned to temp node, and now this previous is pointing to 16 and current is pointing to 9. So current will now become 17 and previous as next will become 17. Previous will become previous will remain the same. Previous is next will be current's next, and current will be current's next. It may take a while for this logic to sink in, but if you mentally work through this again and again, it will become clearer and you will feel that it's easy as you do it repeatedly. Now it's time to insert this new node at the appropriate place. So let's call this function insert node in ascending order. I will pass this temp node as the argument to this function.